Let's look at the problem 120 triangle. So we are going to give a solution using dynamic programming. So the problem itself is sort of routine. However, the interesting point is that the DP table we are going to use here is a triangle. So, but the essence is the same as the usual dynamic programming tabulation solution. So first, I will walk through the statement of the problem. Then we will analyze an example to emphasize a subtle point. Then we will write a brute force DP solution and an in-place DP solution. First, let's look at the statement of the problem. So we are given a triangle array. So we are required to return the minimum path sum from top to bottom. So for each step, we may move to an adjacent number of rows below. More formally, if we are on index I on the current row, we may move to either index I or index I plus 1 on the next row. So the constraint about the problem, one is about the triangle itself, which is not empty and have length bounded by 200. Also, from the third constraint, we see that the number of elements in the rows increases as the index increases. So each time by 1. So now let's look at the example and method. So the method we are going to use is the dynamic programming solution. And so here we will use a DP table like this. So the ij means the ith-row element in the triangle array. dpij, well, it means the minimal path sum ending from the top and ending at the ij element of the triangle. So the relation actually is very easy to plot. Imagine currently we are in this index. So there are only at most two ways we can arrive at the current index. It's from this index G or this index I minus 1, G minus 1. So I minus 1 here means the above row. So the largest index in the above row is the same as this current index G, or 1 smaller. So then with this point specified, so the recursion relation is like this. So where we can arrive here, if we arrive from this index, I minus 1j, then the current path sum will be dp at this index plus the current number at the triangle ij. Let's call it say triangle ij. Or it can arrive from here. I just copy this and change this to be g minus 1. So this relation is not precise because we need to make sure that g and g minus 1 are in range. The in range will mean that they must be greater or equal than 0 and less than the length of the I minus 1 row. That is triangle I minus 1. So with this generic recursion relation specified, let's look at one example. So in example 1 here, so the best path is 2, 3, 5, 1, so which has a sum 11. But in this example, so the path is achieved by selecting the minimum element in each of the row. But in general, it may be not the case. So let's look at a variant of this example. So let's consider this example 2, let's see, 3, 4, and say 6, 5, and let me change this to be 99. Let's say larger. So then let's look at 4, 1, 8, and let's see, negative 10,000. So yeah, for this one, the best path actually is from 2 to 4 to 99 to negative 10,000, right? So, but if we choose the minimal one training at each previous step, we are going to have this such a path from 2 to 3, from 3 to 5, but we cannot arrive at this index anymore. So we can, from 5, we can only arrive at 1 or 8. So then we will choose 1. But due to this negative number, the overall path sum is smaller in the first case rather than the second case. So with this point emphasized, let's look at the code. First, I'm going to write a brute force DP. So for this, let me first track the length of the triangle array. And then I will specify the DP. So I will use a dictionary representation. So at the very beginning, the first index, so we set it as triangle 0, 0. In other words, the first or the top element. Then we are ready to iterate. So for I in range 1 to n, in other words, start from the second row. Then for each j in range length triangle I in the current, we traverse the current row. Then we are going to set this dp ij. So for this purpose, because we are trying to achieve minimal path sum, I will introduce a temporary variable for convenience. Let's call it float infinity. Then basically we will check if I-1 j is in dp. In other words, this will check if the index j is in range. So if this is the case, I'm going to update this temp to be minimum of the previous stage and the dp, so I-1 j plus the current triangle value, triangle ij. Then I do another check, that is I-1 j plus 1, if this is in dp. So basically, I will copy this one. Then I will update the temporary variable again. But here, we're going to change this one to be j minus 1. So with that fixed, so we are going to set this dp value at index ij to be the temp. So once we are done this, so we are ready to return the result. The result will be the minimal of dp with the row index equals n-1 for j. So here for j runs from 0 to the length of the last row, triangle n-1. So by now we finished translating the recursion relation to the current code. Let's try a special case. So this will pass the special case, and also let's try this one. It passes the case. So now let's submit for generic case. So it passes the generic case. So let's look at the problem again. So here is a follow-up. Could we do this using ON extra space? So actually for this, let's try to modify a little bit about the current code to make it in place. Because once we realize the recursion relation, we can update the DP table at the triangle array itself. So for this, I'll write a DP in place solution. So first, again, I'll track the length of the triangle just for convenience. Then I'll update the element as the triangle. So for I in range 1 to n, again, starting from the second row. Then for j in range, again, the length of triangle I. Then again, I'm going to introduce a temp variable just for convenience. Temp float infinity. Then I'm going to check, I'm going to look at this two position, I-1 j and I-1 j-1, right? So at least one of them are in range. So we just need two checks. If j is in range, say j less than length of triangle I-1 here, the last row. So basically, if this is the case, I would choose a minimum between the previous stage of temp and triangle I-1 j plus the current triangle number. Or we can later update that, but it's fun. And then we can try to check again, but for index j-1. So for j-1, if j-1 is also in range, then we can do the minimum again, but this time for j-1, right? So once we done this, basically we can set triangle ij equal this temp. So once we're done, so basically we just need to return the minimum of the last row in the triangle. n-1. So let's check this solution. So let's undo here. Past this case, let's try this case. Yeah, it passes this case. Then we can submit for the generic case. So here, actually, we want to make one more comment. So for the writing about this, actually we can comment, we can update this. Like we can change a little bit here, and just copy this them. So here, actually we can use temp. We do not use here. We do not use here, but we update this here. So it's actually the same effect. So if we submit for the generic case, it passes. I guess that's it. Thank you very much.